The other way to bring data inside Pinpoint is to make the method and bring in the proteins and peptides all inside Pinpoint, and then do the data analysis. So let's do that. First, let's bring in the proteins. A bunch of options available here. The simplest is if you know the GI number. I know that I'm interested in apolipo A1, and the GI number for that is 11392. So I'll just type that in here. Click Add Proteins, and that brings in that sequence from the PubMed database. The second option is if I know the protein sequence or the peptide that I'm interested in, I can just type that here and give it a particular name. I will say it is a peptide so that it does not get triptych cleaved. And as you can see, it's already listed as a peptide under my protein. The third option is to go from any of these four options. Clicking this will download the entire human RefSeq database for you, which might take a couple of minutes depending on your internet speed. But once we have that, it will populate this grid with the entire human RefSeq database, and then we can pick and choose any particular protein from there. So this is a list, and let's say we are interested in apolipoprotein B, let's say. I've written the keyword apolipo, and that takes out all the proteins that have that particular keyword, and let's say this is the protein I'm interested in, and then I'm interested in albumin. And that could be, let's say, this protein. And as you can see, it remembered my previous option, previous selection. So this you can do iteratively. Just keep adding proteins one after the other, and I'll take these two proteins and add those. And as you can see, these two proteins also got added. Let's say I'll add my third protein from my previous discovery experiments, and let's clear this grid. I'll go to Spectral Library, Add Library, and this can take a bunch of formats which are listed here: the Thermo Sys software, Proteome Discoverer, Bioworks, and some public formats. We will add a particular Proteome Discoverer file to this, and we can add more if we want. All the identified proteins are listed here, and I can select, I can filter it the same way, but because there are very few, I don't need to filter that. I can add bovine catalase from here and add that. The difference in adding things from the library, all the identified peptides immediately get added as well. So anything that has a library match will be shown in red, and which are listed right under bovine catalase. And at all times, here is a counter that keeps track of how many things we have. So total we have 5 proteins in here: the ApoA1, this my protein that we added, and ApoB, and serine inhibitor, and bovine catalase. And in total we have 10 peptides, 9 from the library and 1 here. So we have not yet digested these 3 proteins, and that's what we're going to do right now. So we'll go choose peptides, and we can take a standard triptych digestion parameters, use trypsin, peptide length between 7 and 25. We're not doing any blast kind of search. We could do to remove redundant sequences. These are some predictive collision energy settings. We're going to be working on monoisotopic masses, and we can say digest proteins using above rules. We have 3 proteins which are not yet digested, but now they are. So ApoA1, you can see these are the peptides which got triptych digested, and for ApoB, these are the ones, and for serine inhibitor, these are the ones. For bovine catalase, we didn't have a sequence in there, we just brought the identified peptides from the library, and so these are the identified peptides. So now our counter goes to 59. Let's say also for ApoA1, we have the library as well that we have seen in our discovery experiments. We go in here. Now because everything is digested, that's why all of these options are disabled. We can go pick peptide from spectral library and add in our library here. It will try and bring in the retention times, identified retention times for those peptides from the library. That helps in building a schedule method, which we'll cover in the advanced section. But we can click yes, so that it helps bring the raw files, the identified retention times as well. And now if we click apply library and close, it's going to try and bring in all the peptides from the library along with the ones which are digested for ApoA1. Okay, so let's go over this list. Total 66 peptides. So ApoA1 has some black colored and red colored peptides. The ones which are black colored are the ones which were identified by triptych digestion, and the ones which are red colored are the ones which have a spectral library match and possibly a triptych digestion as well. So that's ApoA1. This MyProtein is the one that I just added initially, having a single peptide, and these two are the ones which were generated only by triptych digestion, and this is the one which was brought in only from the library. So a variety of peptides and proteins that have been brought in. Here we're just showing you all the options. Most likely in one particular workflow you'll be using only one single option here, but I just wanted to show you all the various options which are there. Some additional information that we can see about these peptides. Which of these are in silico digested? You can see these ones are. This one was brought in from the library, and so it is. There's a no here. And for example, this one was a triptych digest as well as seen from the library. So there's a yes as well as it's colored red. And for ApoB and seen inhibitor, all of these are yes. And for O1 catalase, there are some no and yes, depending on if it was triptych or not. We can see our library retention time identified for these peptides and the charge states they were seen in. We can also see the number of basic residues in the sequence. Again, kind of helps us in confirming what charge states we might see these peptides in. For example, you can see this peptide has 4 basic residues, and it was seen in 2 and 3. So kind of the same thing, that this sequence has many basic residues. Okay, so now that we have our peptides in here, let's bring in some transitions. So let's start with this particular peptide, and we'll click Add Edit Transitions. Here's some B and Y ions. We can select for +2 precursor and +1 product. We can select some ions. By some fragmentation rules, it will predict the most intense ion, which is Y7 here. So we can take some and add those. They're listed right underneath that peptide. If you want, we can even select some other ions for this peptide. We go in here and we can, let's say, select some +2s. Now if you were to click a library peptide, which is right this one, let's say, and do the same thing, add Edit Transitions. Along with our B and Y fragment series, we also see our MSMS spectra underneath that, besides that. So these ions, B4 and Y10, have a number right next to that, which is explained right here. Intensity from library spectra is given in parentheses. So this number is the CID intensity coming in from our LTQ Arbitrap experiments. And so that helps in judgment, saying what ions should we be picking. So the ions which are most likely high intensity in our discovery experiments would also be high intensity in our triple quad experiments. So we can pick this ion and so on and so forth. We can do that. So we have some ions picked for this peptide, some ions picked for this peptide, and we can keep doing this peptide by peptide. All of this can also be done in batch mode. So let's delete these transitions and do this thing in batch mode. I'm just pressing delete to take out all of these transitions, and I can do that on the peptide basis as well. I can just select this peptide and delete if I don't want this from my workbook. And I can take this protein out also if I don't want, just press delete and the protein goes out as well. Okay, to do transitions in batch mode, we can either select a peptide and then add a transition and go to batch mode, or if we are selected on anything other than a peptide, for example if we are on a protein, that option will open up by default. So to pick transition by batch mode, let's pick transitions first for the library peptides, which are the red colored. We'll go all spectral library peptides and include peptides that do not follow in silico addition rules, for example which ones are non-tryptic or had miscleavages. We will take all of those peptides, and for transitions we'll do based on spectral library. We'll do from the CID spectra, we'll do the top 8 ions, and or maybe top 4, and include all charge states. So if the peptide was identified in +2 and +3, 4 transitions will be chosen from both of those states. We will cover ISRM in another advanced video, so we'll ignore this option for now. While choosing ions, we can do either just Y ions or B or Y. We will do just Y ions because in most triple quad assays we see mostly Y ions. We'll click build transition list. So for every single peptide which has a library match, the software will go to the corresponding library and pick out the top 4 ions for all the charge states which are identified in, and will concentrate only on the Y ions. So you can see for this particular peptide, now we have 4 ions listed underneath that, and for this peptide we have 8 ions because 4 in +2 and 4 in +3. We still have not worked with our non-library peptides, which are these black colored peptides, and for that we'll click add transitions, and let's go to batch mode. Now we'll select the first option, which is all peptides that follow in silico digestion rules, and because we have already picked peptides transitions for peptides having a spectral library match, we'll unselect that. For transitions, we'll do a complete range from Y3 to last ion -2, and precursor +2 and product +1. This will go after all the black colored peptides and build transitions from Y3 to last ion -2. So it could be 3 ions for some, it could be 10 ions for another one, depending on the length of that peptide. This addition of transitions is additive. So as you can see, the ions were picked up for all of these peptides as well, and now our total count is 408 transitions. We are targeting 4 out of 4 proteins, 64 out of 64 peptides, and 408 transitions in total. This option of adding transitions is additive. I can go back in here and now add some precursor +2 and product +2 as well if I wanted to, and it'll just keep adding to the list.